Hi, so today I will be presenting the molecule octane. So the standard electron configuration for octane is 1s2, 2s2, 2p2, and the shorthand configuration is helium 2s2, 2p2. And on the right hand side, you can see the energy level diagram with 2 electrons in the 1s level, 2 electrons in 2s, and 1 in the 2px and 1 in the 2py, so 2 in the 2p overall. And in the octane molecule, there are 8 carbon atoms, with carbons 1 and 8 being the trigonal planar, and carbons 2, 3, 4, 5, 6, and 7 having the linear shape. And that is being carbon 1, the very left side, the very first carbon atom on the left side, and carbon 8 being the last molecule on the right side. So octane is an alkane molecule, and for the formulas, there are 8 carbon atoms and 18 hydrogen atoms. And on the top here, you can see the full structural formula, and on the bottom, you can see the condensed structural formula. And for the reactions, I chose to do combustion and substitution. So for combustion, octane reacts with 5 oxygen gas molecules to create 1/2 oxygen gas molecules and 9 water molecules. And for substitution, octane reacts with fluorine gas to substitute one of the fluorines for a hydrogen atom and also create a hydrogen-fluorine bond. So the molar enthalpy of combustion for octane is negative 2,366 kilojoules. And I found this answer by subtracting the moles times the standard molar enthalpy of formation of the reactants from the moles times the standard molar enthalpy of formation of the products. So the standard molar enthalpy of formation for water is negative 286, and for oxygen it's 0. So I multiplied 1/2 moles of oxygen, because that's the coefficient for oxygen, by 0, and I added that with 9 moles, because that's the coefficient for water, by negative 286 kilojoules per mole. And I subtracted 1 mole times negative 208 kilojoules per mole of octane, and I added that with 5 moles times 0 kilojoules per mole of oxygen, and that gave me negative 2,366 kilojoules. And now here are some interesting facts about octane. So for one, octane is commonly used in fuel. It's the most important part of gasoline because it is the part that lets out the most of the energy, and higher octane fuels are less explosive. And 2, octane measures the ability to resist auto-ignition. And auto-ignition is the ticking noises made when you press the gas pedal. It's the noises made by the engine. And the higher the octane, the more compression needed for ignition. And octane also plays a key role in engine performance. And that is all. Thank you for listening.